Picture this. You have just walked through the glass doors of your local gym, or, I don't know, maybe you were stepping into a massive grocery store.
Right?
The music is pumping, the fluorescent lights are humming overhead, people are moving with purpose. You grab the handle of a shopping cart, or maybe you reach down to pick up a solid metal dumbbell to splint your first set. It feels completely normal.
Just part of the daily routine.
Exactly, it's just Tuesday. But what you can't see, what is completely invisible to the naked eye, is that you have just stepped right into the middle of a bustling microbial metropolis. And today, we are handing you the microscopic glasses so you can actually see it.
Yeah, it's a fascinating and honestly slightly terrifying reality when you look closely at these high-traffic public spaces. We tend to view gyms and retail environments purely in terms of their function for us, like a place to buy food or a place to build muscle.
You
Right. But biologically speaking, these spaces, and specifically the high-touch surfaces within them, they serve as primary reservoirs for pathogens. So we're really looking at the perfect intersection of human behavior, microbiology, and materials engineering.
And that intersection is the exact mission of our custom deep dive for you today. We are unpacking a massive, fascinating stack of research, product literature, and patent designs surrounding an upcoming product called GripGuard.
It's really interesting stuff.
It is. It's this new physical barrier technology attempting to solve a major, largely ignored hygiene challenge. We are going to explore the microbial reality of what is living on that gym equipment, why our current methods of, chemical cleaning are fundamentally falling short, and how the latest materials engineering is trying to physically blockade the germs.
Yeah, and before we can analyze the engineering of the solution, we have to confront the biological scale of the problem because the research data on the equipment you use every day is, it's genuinely eye-opening. When scientists actually swab these surfaces, the colony-forming unit counts, which is the standard measure of bacterial contamination, they are just immense.
Yeah, I was reading through the swab results and the sources,
Hmm.
and they compared the bacteria levels on gym equipment to a toilet seat. Now, usually, that is the gold standard for contamination testing.
The classic benchmark.
Right. But the data shows some gym machines harbor up to 362 times more bacteria than a toilet seat. Like, that is wild to wrap my head around. And if you hop on an exercise bike, that bike is 39 times more germ-riddled than a standard cafeteria tray.
And you also have to consider the specific profiles of those colonies, right? We are not just talking about harmless, ambient, environmental bacteria that you would find, say, on a tree branch.
Right, not just dirt.
Exactly. The most prevalent type of bacteria found on these athletic surfaces is Staphylococcus, but the pathogens frequently detected also include E. coli, MRSA, Salmonella, and Pseudomonas.
Wow. So the big hitters.
Yeah, serious organisms. These are capable of causing skin infections, gastrointestinal illness, respiratory issues, basically whenever they find an entry point.
Okay, let's unpack this, because this is where the mechanics of it seem, I don't know, counterintuitive to me. The research identified dumbbells as the absolute dirtiest weight equipment tested. But dumbbells are just solid pieces of cold, hard metal.
Right.
They aren't porous like a sponge. They do not absorb anything. How on earth does a smooth metal handle become the dirtiest equipment in the entire room? Is it like shaking hands with 100 strangers during flu season?
Well, this raises an important question about how bacteria survive outside the body. You really have to look at the human biomechanical input during a workout. People are exerting themselves, their body temperature is elevated.
They're running everywhere.
Right, they are sweating, and they are shedding microscopic dead skin cells and natural skin oils. So when a user grips that cold, hard metal, they leave behind a microscopic layer of moisture, warmth, and organic biological material.
I see.
And that residue, it is an absolute feast for microorganisms.
So every single person who picks up that weight is basically depositing a fresh layer of biological food onto the surface.
Exactly. And that biological food source leads to what microbiologists call biofilm accumulation. Bacteria do not just land on a metal surface and sit there in isolation.
They build a little house.
Pretty much. As hundreds of people touch that same handle, the bacteria begin to secrete an extracellular polymeric substance, which is essentially a sticky structural matrix.
That is so gross.
It is. They build this protective microenvironment that physically anchors them to the metal. This biofilm creates a permanent reservoir where even aerobic bacteria can thrive because the constant exposure to the open air and human contact provides everything they need to multiply.
So the metal itself is inert, obviously, but it is coated in this incredibly active living layer of infrastructure. So you are probably wondering at this point, what about the wipe down? Like, every gym has those giant dispensers of antibacterial wipes. People wipe down the bench, they wipe down the handles. We have this entire social ritual of the gym wipe down that is supposedly meant to handle this exact issue.
Right. The chemical wipe down is currently the standard infection control practice in these environments. We are relying entirely on chemical interventions to reset the biological environment.
Here's where it gets really interesting, though,
Yeah.
because the sources show that this chemical reset is essentially an illusion.
It really is.
If I scrub a bench with a heavy-duty chemical wipe, the assumption is that the bench is now sterile, right? But the text highlights a study finding where 63% of machines still showed traces of rhinovirus, the virus that causes the common cold, even after being actively disinfected.
Yeah, that 63% retention rate comes down to two major flaws in how we approach surface hygiene.
Okay, what's the first one?
The first is chemical contact time. For an antibacterial or antiviral chemical to actually penetrate that sticky biofilm matrix we just talked about and destroy the pathogens, the surface typically needs to remain visibly wet for several minutes.
Oh, wow. Minutes.
Yes, most gym goers do a quick, maybe 3-second swipe and immediately dry it off with a towel or just sit right down on it.
Yeah, nobody is waiting 5 minutes between sets for the spray to dry.
Exactly. The chemical evaporates or is wiped away long before it can actually do its job.
It makes a lot of sense. So is the gym wipe down just hygiene theater? Like, it sounds like putting a tiny Band-Aid on a bursting pipe.
That is a perfect way to describe it. And the second flaw has to be the sheer volume of traffic. Even if someone were to meticulously soak the dumbbell handle and, wait 5 minutes for perfect sterilization, that state of perfect hygiene vanishes the exact moment the next person starts their set.
Because they are immediately putting a new layer of sweat and bacteria right back on it.
Exactly.
Yeah.
The literature identifies this exact phenomenon as unsanitary constant reuse.
Unsanitary constant reuse.
Right. Wiping down a high traffic handle is like trying to paint a bridge while the cars are still driving over it. The intervention is completely temporary.
Wow.
Within 60 seconds, the next user grabs the handle, deposits a fresh layer of sweat and whatever pathogens they happen to be carrying, and the cycle of cross-contamination resumes. The chemical wipe simply cannot offer ongoing, persistent protection in an environment defined by continuous human contact.
So because that chemical wipe fails almost instantly in a high-traffic setting, engineers had to basically look past chemistry and move to physical barricades. Since we cannot permanently sanitize a surface that is constantly being touched, the logical step is to create an impermeable wall between the user and the biofilm reservoir.
Right.
Which brings us to the design patents for GripGuard.
Exactly. If you cannot eliminate the reservoir, you isolate the user from it. The product literature for GripGuard describes it as a hygienic disposable wrap or a sleeve designed specifically for exercise equipment, sports gear, and grocery carts. The patent filings focus heavily on preventing this cross-contamination through a persistent physical barrier, and they achieve a measurable reduction in the risk of spreading infections.
Okay, theoretically, putting a physical shield over the germs makes total sense. But practically speaking, what does this all mean for the actual workout? Like, if I am at the gym about to bench press and I slide a smooth plastic sleeve over a heavy steel bar, the coefficient of friction is going to completely plummet. Right.
Literally, yeah.
Isn't my hand going to slip right off and drop a 50-pound weight on my feet?
No, this is exactly where materials engineering has to intersect with biomechanics. You cannot compromise athletic safety for cleanliness.
Because nobody would use it.
Right. When you look at the design patents for these disposable covers, they are constructed as flexible tubes that fit snugly around a handle, but they are far from being just smooth plastic bags.
So they have texture.
Yes, the advanced designs incorporate specific topological features, so corrugations, ridges, or bumps built directly into the material structure.
So they are texturing the barrier to compensate for the loss of friction against the metal.
More than just compensating, those corrugations serve multiple biomechanical purposes. First, they drastically increase the friction between your hand and the sleeve, and simultaneously between the sleeve and the equipment handle.
Oh, so it grips the bar itself too.
Exactly. This ensures a firm, non-slip grip even under heavy dynamic loads. The ridges are designed to compress and actually lock into the natural contours of the human hand.
That is brilliant. And I also noticed in the material specifications that these ridges create tiny air spaces between the user's skin and the barrier material itself.
Yes, and that is a crucial piece of the structural geometry. When you are lifting weights or pushing a heavy cart, your hands perspire.
Yeah, obviously.
A completely flat, non-porous material wrapped around a handle would trap that sweat instantly against your skin. It makes the grip uncomfortable and inherently slippery.
Like wearing rubber gloves on a hot day.
Perfect comparison. By engineering these specific geometric air spaces, the material allows for a continuous airflow. It increases user comfort and maintains grip integrity, all while keeping an absolute impermeable barrier against the biofilm on the actual handle underneath.
So they're achieving a measurable reduction in the risk of spreading infections through like structural design rather than just chemical application.
Exactly.
Okay, so the physical barrier solves the germ transfer. But what about the sensory experience? I mean, anyone who has looked into the biology of a workout knows that sweat itself is virtually odorless, right?
Right. Fresh sweat doesn't smell.
Yeah, it is the bacteria breaking down the proteins in that sweat that creates the dense, heavy gym smell. So putting an impermeable barrier between you and the biofilm should theoretically help with the odor too.
It does. But the literature says these grip guard sleeves actively fight the smell beyond just acting as a wall. Bacteria are the primary cause of malodors, those sweat and body odors, in exercise environments. The bacteria living on your skin and thriving in those biofilms, they consume the proteins and lipids in human sweat. As they metabolize those compounds, they excrete volatile organic compounds, which is the bacterial waste you are actually smelling.
So the designers recognized that a true hygiene solution needed to address the olfactory environment, not just the tactile one.
Exactly. Sleeves can incorporate malodor counteractants to neutralize smells.
But wait, the idea of a heavily perfumed gym equipment sleeve sounds awful to me. Like when public spaces try to cover up body odor by pumping the air full of heavy floral scents, it just smells like pouring cheap cologne on a trash can.
It's the worst.
It really is. You aren't fixing the smell, you're just creating a confusing, overpowering mixture. So how does a disposable wrap actually neutralize odor at the molecular level instead of just covering it up?
Well, what's fascinating here is the difference between olfactory masking and molecular neutralization. Masking is the cheap cologne approach you described. You attempt to overwhelm the olfactory receptors in the nose with a stronger scent, so you just do not notice the foul one. But the technology proposed for these sleeves operates on a fundamentally different chemical level.
How so?
They incorporate what are known as malodor counteractants. The sources detail specific technologies, primarily silver-based tech, alongside chemical formulas containing compounds like apelide or diphenyl oxide. These counteractants work synergistically to block odors at the molecular level.
Oh, I saw the silver-based tech mentioned in the patents. Is the silver acting as a physical blocker, or is it disrupting the bacteria on a, cellular level?
It is a cellular disruption. Silver ions are highly antimicrobial. When they are integrated into the polymer matrix of the sleeve, they actively penetrate the cell walls of bacteria that come into contact with the surface.
Wow.
Yeah. Once inside, the silver ions disrupt the bacteria's cellular respiration. If the bacteria cannot metabolize, they cannot consume the sweat, and they simply cannot excrete the volatile organic compounds that cause the malodor.
So you are neutralizing the odor at its source by shutting down the microbial metabolism entirely.
Exactly.
That handles the bacteria on the surface. But what about the compounds like apelide and diphenyl oxide? Are they doing something different to the air around the handle?
Yes. Those specific malodor counteractant formulas work synergistically with the silver. While the silver inhibits new odor from being produced, compounds like diphenyl oxide interact with the volatile odor molecules that are already airborne.
How does that work?
While olfactory receptors in your nose work on a lock-and-key mechanism. A specific odor molecule fits into a specific receptor, triggering the brain to register a foul smell. These counteractants bind to the bad-smelling molecules in the air and literally alter their molecular geometry.
Like changing the physical shape of a key so it no longer fits into the lock.
A very accurate way to visualize it.
Huh.
The altered molecule is still physically present in the air, but because its shape has been changed by the counteractant, it can no longer dock into the odor receptors in your nose. Your brain simply stops registering it as a foul odor.
That is incredible.
By combining the physical barrier, the silver-based metabolic disruption, and these molecular counteractants, the engineering achieves freshness at a molecular level, entirely bypassing the need for heavy, masking perfumes.
It is fascinating how much deep science is layered into something that at first glance just looks like a plastic wrap for a dumbbell. We started this deep dive looking at the staggering bacterial loads on gym bikes and weights, realizing that the cold metal is actually covered in a living, sticky biofilm.
A whole microscopic world.
Yeah. We explored how our trusty chemical wipes are essentially failing because you can't sanitize a surface that is constantly being touched by a new person every 60 seconds. And we have seen how material science is responding by engineering flexible, corrugated, silver-infused physical barriers that not only block pathogens but neutralize odors by literally changing the shape of the molecules in the air.
Yeah, and if we connect this to the bigger picture, this kind of materials engineering fundamentally changes how you might perceive your environment. The next time you grab a grocery cart handle or a dumbbell, you will likely be acutely aware of that invisible microbial ecosystem. You will understand the biofilm mechanics and the sheer volume of biological data being transferred from person to person.
Yeah.
But you will also recognize the sophisticated layers of biomechanical and chemical engineering required to actually combat it effectively in a high-traffic space.
You will definitely never look at a dumbbell the same way again. But before we wrap up this deep dive, there was one final provocative thought I want to leave you with.
Okay.
The sources we explored today present an incredibly compelling, scientifically backed case for using single-use physical barriers like GripGuard to protect our personal health. I mean, the data on cross-contamination, the failure of chemical wipes is undeniable.
The data is very clear, yes.
Yeah. But here is something for you to ponder on your way to the gym or the grocery store today. If this physical barrier technology scales, if every single gym goer and every single grocery shopper starts using single-use disposable sleeves on every single handle every single day for perfect personal hygiene, how will society reconcile that massive, unprecedented new stream of daily plastic waste with our urgent need for environmental sustainability?
That is the big question.
Are we simply trading a biological problem for an ecological one? In a profound tension between the immediate health of our bodies and the long-term health of our planet, and it's a question we are all going to have to navigate very soon as these technologies hit the market.
It's definitely something we all need to be thinking about.
Thank you so much for joining us on this custom deep dive. Keep asking those big questions, keep looking closely at the unseen world around you, and above all, stay insanely curious. We will catch you next time.